Hi everyone, I'm Eason. Today I'll be presenting my final year project titled AI-based fatigue detection for team-based sports player performance optimization. This project is under the guidance of my supervisor, Associate Professor Muhammad Azam. Let's dive into what actually inspired us to come up with this project. Fatigue is a critical factor affecting both athlete safety and team performance in competitive sports. Imagine that you're a coach for a basketball team. If you are able to understand each of your players' physical state condition, you will have an advantage in making strategic adjustment, reducing the risk of your players' injury, and gain a winning edge in every match. Through our research, we found out that fatigue management remains an under-addressed factor in sports. Conventionally, coaches and players have relied on subjective evaluations such as personal judgment and gut feeling, which might lead to inconsistent decision making that costs your team the whole game. Another challenge that our project seeks to address is the limitation of existing fatigue detection technology in the sports industry. Currently, in the market, most of the fatigue detection technology relies on wearables, which might cause discomfort in players during matches. The goal of our project is to create a system that is able to detect and identify players in basketball match footage using YOLO V8 object detection model, track player movement patterns across video frames using an LSTM model, estimate player fatigue levels by analyzing movement speed and posture variation using a GBM model, and to develop an interactive monitoring interface that can visualize player fatigue levels. So, the proposed solution that we have come out is Team Speed Spot Fatigue Detector. So, what is Team Speed Spot Fatigue Detector, you might ask? It is a desktop application that uses image processing and various deep learning models to analyze a basketball video match. It is able to track and analyze players' movement speed and posture to detect for fatigue indicators, and the objective is to provide actionable insights for performance optimization. There are three main intelligent components in our system, which are YOLO V8, LSTM, and GBM. YOLO V8 will be used to detect and track basketball players in match footage, perform post-estimation, and detect the key points on the basketball court which is needed to calculate the player's speed. Then the LSTM will analyze the temporal changes of the player movement speed and posture across time. Finally, the GBM will use the derived features from LSTM to estimate and classify player fatigue score based on historical and current performance data. For our AI-based fatigue detection system, it consists of 4 different modules. First, we have the video analysis module, which is responsible for detect and tracking the players, and as well as detecting the key points on a basketball court, which will be used to calculate the player speed. And then next, we have the fatigue detection module, which is the main component of our system, which will handle tasks such as movement analysis, posture analysis, and player fatigue indicator. The desktop application interface module is where the user will interact with the system by uploading video and viewing the result report. And finally, the cloud service module will handle the heavy computational load of the system by allowing data storage and hosting the deep learning models. Here's a simple architecture diagram of our system. So first, the user will upload a match video footage to the desktop application, where the front end will send a fast API request to the backend services, which is hosted on a platform called Model. Here we will find our deep learning models, which is trained on Google Colab using Kaggle's TeamTrack dataset. And once the video analysis has completed, it will send the data to the MongoDB Atlas cloud storage to be stored, which will then be sent back to the desktop application for the user to view the result report. For now, let's go to the system demo where we will demonstrate our application functionalities. Welcome to TeamPeak Spot Fatigue Detector. This is the homepage for our desktop application. Here is where the user will be able to select the basketball video footage that they would like to be analyzed. So let's click on here and we can choose a video footage that we would like to be analyzed. So once the video has been uploaded, the system will start to analyze the video frame by frame by applying the object detection model, post-estimation model, the court detection model, LSTM network, and GBM model. As there's a lot of heavy computationing on the back-end service, so the processed video might take some time to load. So this is the monitoring interface for our desktop application. Let's maximize the video player to have a better look at the result. For each of the detected player, they are assigned a player ID. And we can see that there are 6 key points detected across the basketball court, which this key point will be mapped to real-world coordinates of the length and size of a basketball court. How fast the player model moves across relative to this key point will be used to calculate the player's movement speed. Let's take a look at the top right corner. We can see on the table, the first column is the player's ID, the second column is the player's movement speed, the third and fourth column will be showing the player's head tilt and body slouching angle. For each of the player, the system will calculate a baseline of how much the player tilts their head and slouch their body throughout the match. If the higher the player deviate from their baseline angle, the higher their fatigue score will be. Same goes to the movement speed as well. The slower the player's movement speed, the higher their fatigue score will be. And the fatigue level will adjust according to the fatigue score. Let's have a look at the result report. So on the left side, we can see there's a fatigue trend visualization graph showing the trend of their activity throughout the match, and on the right side there's a summary of the players matrix including the current fatigue, average speed, maximum speed, current speed, average head angle, and average body angle for each of the player. It's a very simple application, and let's look at another sample case. Let's head back to the homepage and select another video to be analyzed. Go to sample tree, press next. We'll speed this up and fast forward the video. So here's the example of the second process video. So the fatigue level will be adjusted according to the fatigue score. From 1 to 20, the player fatigue level will be considered very good. From 21 to 40 is considered good. 41 to 60 is medium. 61 to 80 is fatigue, and 81 to 100 is very fatigue. And the fatigue score and fatigue level is color coded, so it will get more red in color as the player get more fatigue. Let's look at the result report again. So it's almost worked the same way. And that's it for my application demo. From the system demo, we can see that we have developed a system capable of detecting player fatigue through data-driven assessment and established a solid foundational framework for a scalable solution that can contribute to future advancement in sports analytics. There are also plenty of entrepreneurship opportunities for this system. First, it can be packaged as a subscription-based service for sports academies, professional teams, and fitness centers to monitor athlete fatigue and optimize performance. Furthermore, it can also be integrated with existing team management platform to enhance traditional tactical dashboards with physical condition monitoring. That's it from me. I hope you like it. Bye bye.